I mean, they're like, it has a lot to do with the credibility of the person, you know, like if it's some unknown person doing something, I mean, it is what it is, you know. I mean, if it's somebody that you know who does stuff, you know, or whatever, then you have to kind of go by their word on it. But I mean,
Mm-hmm.
unless it, you know, the best video that you're ever going to see, you're going to think is fake. You know what I mean? So, I mean, I don't know. You know, to me, video evidence is just inconclusive now. I mean, unless you're there, you know, with other people or whatever, that's the only really
Yeah,
validation that you're going to
yeah.
have. Because no matter how you shoot a video, the videos don't come out like what you see. I've been out here too many times. I've
Yep,
dealt with
yep.
so many of these craft that when I video, every video I do comes out differently. I don't know how to explain it, but like when
Mm-hmm.
there's certain phenomenon with lights out there, and I've had like a ball of energy light or whatever that I was 20 feet away from that was going in the ground and coming out 7 miles away on the other side of the mountain and then coming back to that spot. And it did it a bunch of times, and it was like posing for me. And that
Mm-hmm.
was like my best video. And that was like the video that got shredded, you know, by that shredder or whatever that I saw the, you know, the videos and stuff, but some of them are irrefixable or whatever. But when I looked at that object through, and I was looking through a binocular at it, you know, even though it was only 20 feet away, I was trying to look as close as I could. The light that I was seeing visually versus what I videoed was totally two different things. Like what I saw in the video didn't even resemble what I was looking at with my naked eye. It looked like a saw blade rolling through the air, like, you know what I mean, like it was rotating. And I never saw that. I saw it would look like a crystal, almost like a crystally looking light with all different colors coming out of it. And then on the video, it was black and white. It was like completely different. I mean, it was bizarre how it was, but whether
Yeah.
that gave me a different perspective to look at, I don't know. But like a lot of times, these, you know, you're dealing with objects that are at night, that it's dark, and if you're using a camera of any kind that has an automatic focus, it will not focus on these objects at night because they're moving around too fast. They have too much of a contrast of light versus the darkness, and the cameras just have limitations. You know, unless you have a professional camera with
Mm-hmm.
somebody who really knows how to use it well, you're not going to get very good video. It's just, if you do, it's a strike of absolute pure miracle luck. You know what I mean?
Well, that video looks like it's one of these
And
Sony. Yeah, the sensor that he's using on the
that's why like
camera.
people want to see video proof, but it's so difficult to actually shoot. You know, even when you're shooting at a legitimate object, to try to make it look like what you're seeing versus what comes out on the video is the problem. You know what I'm saying? I don't know how the camera eye works on a digital camera, you know, per se, when it comes to how it decides what light is and what isn't versus
Yeah.
the naked eye. You know, I mean, that's where maybe film cameras have an advantage over digital, is that if you know how to work a film camera and have the you know, the speed and everything. But once again, you're dealing with so many contrasts here because everything is light objected, you know, on a camera lens, and trying to get that light just right when you're in pitch darkness and getting that thing to focus, it is totally dependent on the light to focus. And so, I mean, those look like blurs to me, but that's typical what I see when I shoot video, you know, like that, because you're dealing with such, like I said, a low light object up there. Even if it's like as bright as Jupiter, it's still difficult to video. I mean, I challenge anybody to go out with a cell phone and pitch black and try to shoot any video of even an aircraft flying
Well, we
reasonably close. It doesn't work out all the time.
well,
It's really hard to even get it to focus on the aircraft flying by.
okay. So back on the information, he didn't actually tell us the camera type he was using.
What's that?
In the Lufon description, he didn't talk about his camera model or anything like that at all.
Yeah, see, and that kind of helps to know every detail of what's going on here. Because if it was a cell phone, that explains it. But if he's shooting through a windshield, the windshield is curved, and the windshield is going to distort what you see through your eyes versus what the camera sees. It's going to distort it too. And I mean, I've been out where it's super cold and it's really difficult to go outside and try to shoot. You know what I mean? When the things are going on, and I'm shooting through a wind screen, and if the
Mm.
windscreen has any condensation on it, it's going to affect how it looks and all that too. And there's always some kind of condensation on there.
Although
You know what I
that
mean? When it's
sound like
cold
it,
like that, your windshield fogs up.
yeah.
You
Although
know.
I don't think he was inside the car
But
because you.
and that's where I don't really trust any video that's shot through a glass because it's too easy to fake
He didn't say he was
too
shooting through
at the
glass.
same time, because you get a
Hang on,
double
hang
you
on,
get
hang
a
on.
double imposition of an object, because the glass, depending on how thick the glass is, there's going to be an image reflected on the outside of the glass and on the inside of the glass,
Depends
and it can really distort what you're looking at too.
It depends if it's very clean glass and flat glass rather than curved glass. I don't think he's in a car. He's actually filming outside, because you can hear him breathe.
You need to have the camera mounted. You can't hold the camera in your hand. You'll never get a video that's just but a jerky mess. Or you have to rest your hand on something where you're not, where you're only just, you know, guiding it with your hand. If you try to hold it in your hand upright or whatever, anytime, I tell this to anybody trying to shoot video, just take it and walk over to something and just rest your hand on it and then shoot it that way. If you don't have a tripod or something, or it's a cell phone.
Yeah.
So
I think he definitely had it stabilized there before he moved it, because you could see it was slowly moving diagonally, and there wasn't any shaking going on. And he also seemed to be outside, because you could hear the wind in the background and him breathing as well.
Yeah.
So yeah.
Well, what do you think?
Me, I have a feeling that it's a hoax. It's my feeling, because of that extra triangle that comes into the picture there, and the lack of information in the description is a bit suspect to me, because if he saw this amazing footage, right, you're going to describe everything you can in the reports, and rather than just putting a brief comment, you know. You're going to say what model camera you're using, that you're facing a tree and all this sort of stuff, and there's three lamps near you that were reflecting into the lens,
and then
or
also
whatever.
daytime of where you were shooting it from kind of helps too. You know what I mean? Like where it's daytime, so you can see
even some still photographs of where you were at nighttime. Yeah, still photographs of where you were at nighttime as well would help a lot. But in this case, like you said, having a second person.
Most of the objects I've seen, most of the objects that I could identify as being something other than conventional, like a crafted disc or whatever, they were very close to me and almost at ground level, you know, or like right along the ground and stuff. And the ones that are way up in the air that I've seen, all that, they could be in space for all I know. You know what I mean?
But the problem you have is you didn't have anyone with you to verify what you were seeing. Just like you're saying with this.
Yeah, well, on a couple of those occasions, but I do have a person that was with me when we saw the triangle come out of the flash of light up there, and that was quite extraordinary because there was two of them. The first one, I saw the flash, I just didn't see what came out of it, and I was watching in the same area where the flash occurred, and it was about a minute and a half after the first one came out. The second one came out, and it was clearly for a second it illuminated the whole entire craft, you know, as it came out of the flash. And there was it was a pyramid with like the top cut off of it, and it was triangle. I mean, perfect triangle, you know, 3-point triangle. And it had sides to it where it had lights on the side of it that it almost looked like a building. I mean, I don't know how high it was. I couldn't really tell in perspective to anything else because there was nothing else around, and I only had stars in the background. And the minute that the flash was off of it, which was just, you know, for an instant, if I hadn't seen where it would have been almost impossible to see because it was black on a black background, and I could barely see it moving off, and it was moving really slowly at first when it moved off. You know, so I mean, and like I said, it was up there. I imagine it was pretty high. I imagine that the thing was actually pretty large, and perspective to an airplane, it was you probably fit 4 or 5 747s. I'd imagine if I was seeing it at the right, you know what I mean, distance or whatever. But I guesstimate about 4 or 5 747s would have fit on it easily.
Okay, so we did actually look up the difference between thermal and night vision, and here's some good examples here. So on the left side here is an image of a night vision, which shows visible light and up to near infrared, as they call it, and the thermal is on the other side, which isn't actually an image. What it does is it detects only infrared and converts it into a color spectrum image, and in this case you can see there's a person standing behind the door. Now firefighters use that because they can see people in thick smoke, where a normal night vision won't see people in the smoke, but you can see here a person would stand out in smoke because their heat signatures stands out from the heat of the smoke. So that's quite a good image there. So when we talk about the difference between what spectrum the cameras look at, right? We got this nice little chart here of what the sun emits.
You're talking about FLIR. This is a FLIR.
They call it, this is the general term, thermal camera versus night vision.
Right. It's like what the police use on a helicopter. It's a FLIR camera.
Yeah. So a FLIR camera or thermal camera looks at this spectrum here. They call it the far infrared heaters to all the way up to here at the end of the infrared spectrum here, which goes into the microwave. So it's seeing into that region there, and normal night vision cameras are looking into normal spectrum, probably some low-end ultraviolet spectrum at the low end as well. You find that's the case with a lot of the cameras. They're sort of limited by the filters they have in front of the camera. So, they drop out frequencies either side. But in this case, they get near infrared rather than far infrared, they call it. So it's more closely to the start of the infrared. And rather, this is well into the infrared, and they call it like nanometers. So that's a good chart there. I will post the chart there actually because it's quite a good chart. Whether Google's going to keep my things, I don't know. So spectrum chart. So once we know light moves in waves, right? This obviously is looking at waves that are further apart in the cyclone of the sine wave, and this is
you look at
more
on your chart here. Do you see how little the visible light is versus all the invisible light? You know,
yeah, and
it's
we
a very
only
small amount of light is visible.
Yeah, we only see that with our eyes, and we've got all this here, all the other sort of
I didn't realize infrared though was that far off from UV and X-rays like that. It's opposite. It's a really long wavelength then, huh?
Yeah.
But infrared is really long.
Well, that's why they break it up into near infrared and far infrared, I guess. And so if we go to the wiki page on it.
So infrared makes up a very large portion of the light spectrum then, huh?
Yeah, according to that chart it does. So this is the other one.
Wow. I had no idea.
And it gets, let's see, so as you know, you get burnt by UV light, which is this end of the spectrum, which means does it, let's see, as we go that direction, which means it gets faster. What's that say at the bottom here? 1000, is it? Light is not just one single entity with the same properties throughout. We're used to thinking about the colors of the spectrum, which we can see red, green, blue, yellow, and everything in between. But there are other forms of light that are not visible and cause effects like heating. When they hit the objects, they are absorbed by them. Infrared itself consists of different wavelengths of electromagnetic energy radiation. We are all aware of it. So what they're saying, when a photon hits your skin, the atom, it absorbs basically it absorbs the photon into the atom, doesn't it? And causes a vibration within the atom.
Well, actually, when the photon strikes the surface, it releases an electron, and that's what makes it visible light. And the electron is what gets absorbed, and the photon is neutralized. And I guess I'm not sure exactly.
Well, I thought the photon gets absorbed.
I
thought the photon gets absorbed into an electron on the atom, which is then ejected.
Or it becomes an electron or something like that. When it strikes that surface, it creates an arc, and that's where we actually have visible light from. from what I understand.
Okay, but
When it actually strikes, when a photon strikes the surface of anything, it
but
causes
the movement
it to
itself, the movement of it ejecting
right
is releasing energy
to
in
arc,
form of
right,
vibration, which we feel
and
as
it's
heat.
thermal energy. In the release, I think that's what happens to the rest of the photon it gets dissipated from the heat. Like when you go outside and the sun comes up and it's on a black surface and you put your hand down and it's hot and burns your hand.
Yeah.
You know, that's the effect of
But
the what happens to the
UV
photon.
rays are also the same. This is the same as electromagnetic, but it's got
Right.
a what do you call it? A
UV
denser.
rays are actually
Well, it has a denser
tighter ray,
energy.
right? They're like a
Energy. It
purple.
has denser energy, so it penetrates further into the body and causes
Yeah.
burning. It causes more energy release, and
Right.
instead of just heat, it actually is a burning heat, which then causes DNA damage because it can actually it basically it's actually modifying the atoms, isn't it? Which then break down on your body because
Yeah.
we're made up of atoms, right? Carbon and all that. And if UV light interacts with that and changes the carbon bonds, that causes DNA damage. And at the same time, it's releasing extra energy. You know how you get burnt with UV rays, but with infrared, you'll feel hot and warm until you get cooked, right? It takes more energy off the infrared. It's a lower energy, which takes longer for it to burn, like UV light does. So UV light's got more impact, if that makes sense. But yeah, it's a good article here. Did I post that one? I think I did. Showing the difference between the two cameras. So here's another one with visual spectrum or night vision. You can see a tree, right? And that's what I was saying in that last video. Is the tree vertical or is it on the side? It's a bit hard to tell. You can see it's very similar to this tree, how the branches are. And there's actually a person standing there, but you can't see it with the night vision. But if you put thermal onto them, you can see a person standing behind the tree here, even though it's pretty vague because it's only picking up certain heat signatures and making an image out of it. You know, you can see a head, body, and yeah. So surveillance, energy audits to see how much energy is leaking into the atmosphere from your house, deer spotting, and UFO hunting, I guess, and ghost hunting. There's some of the other options there. So I'll just post that one. Yep, I'll close that one down. Just work through this. So night vision device. We've got the Wikipedia on it here, which is another interesting read, which gave us some clues to how they work. So night vision device called an NVD, also known as light optical observation device, NOD, and night vision goggles, NVG, is a optoelectronic device that allows images be produced in levels of light approaching total darkness. So that means you can see starlight. And of course, Sony have released a new sensor called the Starlight sensor, which can pick up almost 0.001 of the lumen, which is almost next to nothing, right? So these new cameras are coming out for security systems, and hopefully will be in low-end cheap cameras from China that you can use for sky watching. Because I did cover that in previous lives, which you can find out about the night vision, the colored night vision. So now they've got colored night vision, which basically, I guess, processing it differently. Instead of it passing through one filter, they're actually probably electronically changing the filter inside the camera, and then combining all the different images into a nighttime color image. So you got your normal spectrum coming in, as well as it's merging the enhanced light from night vision at the same time, so you can actually see like the color of neon lights for this for these new cameras, which is quite interesting. A leap forward, I think. So it'd be interesting to see how the Chinese mass produce those, and it'll get cheaper and cheaper, so you can pick them up for like $30. At the moment, they're like at the moment they're like $200 US, which is quite pricey. But they also come with optical zoom on these security cameras, which you could use as a cheap method of sky watching, I guess. Colored night vision would be really interesting to see if we can catch some UFOs with it. Again, this gave some details here, and it talked about that it sees the visual spectrum to the near infrared, where the thermal carries on from the next level up, pretty much. So obviously it was developed for military use, and now it's been released to consumer level. So yeah, when did the first night vision hit the market, really? They're pretty new technology, really.
It was in the 60s. For military use in this country, it began to be used about, I think, 59 or 60, and then it was tested pretty exclusively in Vietnam with aircraft, helicopters and stuff there.
Right.
And but it became pretty much the first generation, I think, made it through there, and the Russians had a generation of it too. I don't know if they copied it from the United States, or
they
if
probably
they
did.
made their own or whatever. But coming about the mid 70s, they had like Type 3 night vision available on all the military helicopters there.
Well,
it was very expensive, but
it says here first used in
it was
World
probably
War II.
$20,000 a unit, back
So
then,
it sounds like it even goes back to 1944 here, according to this. 1939.
I know there was people playing around with it during World War II and stuff, but I don't think it ever really made it as a manufactured Type 1 until about 1959, I think, or 60 or something. It was like,
and it says here,
because I remember I saw a video on that where they were showing them using it to, in Vietnam to find Viet Cong in the jungle and stuff, and because they would do night patrols, and it was like, it was pretty tough.
Yeah.
And
well, it does say
was
here,
really effective. The problem that they always had until like about Type 4 or 5 was the depth perception problem. But
yeah, it says here in 1929. Yeah, hang on. 1929, Hungarian physicist Carmen Toiheri invented an infrared sensitive electronic television camera for anti-aircraft defense in UK. I wonder how big that was then. The first
this is what I need. I need true night vision. Infrared doesn't work because you have to project the infrared, and it only goes as far as the infrared is projected. But the night vision is totally different. It gathers light from where to us it's invisible.
Well, again,
but it exploits the
yeah. It depends if you're using that new Sony Starlight sensor in the infrared camera. Then you'll be able to see.
They're up to like, I think, Type 7 now or something like that, which the SEALs use and all that. It's super expensive stuff. It's like probably $100,000 for that.
So the Germans were the first to use it, according to here. So maybe the Americans stole the technology from Germany after the war, right?
I'm not sure about whether that could be true. I'm sure that the German scientists back in World War II were working on coatings, because I actually seen sites from a tank sites or whatever that were coated with a.
Well, it says here in this document the Panther tanks had it in 1935. So.
Yeah.
Yeah, looks like.
But as far as having it to where they could actually really use it and utilize it, it didn't really. It took a long time. And the Germans pretty much worked with the United States at that point. So anything that's done out of Germany that's optic or whatever, it's usually from like a DARPA, you know what I mean, that they send out, because obviously the Germans and the Swiss grind the best lenses in the world. You know what I mean? Well,
it says here the first
Zeiss lenses.
Yeah, it says here the first one's range finders and can only go up to 600 meters. I'm not sure if that's useful or not
Yeah.
in a tank. I suppose.
And plus it mess with your depth perception. Like if you ever have you ever looked through that kind of stuff?
Yeah.
The early stuff, especially like the Russian early stuff, you can't tell how far a distance is in them. They're kind of screwed up, you know. I mean, you can see things, but you can never use them to like use them as a sight or anything like that because I mean, or whatever, or to drive with because you drive off a cliff or something, not knowing,
Yeah.
how far things are. It like totally messes with the distance.
Well, it talks about generation 1 to 3 here in USA.
But I've actually had I acquired some night vision at one time that
Yeah.
a buddy of mine gave me for a favor, and it got